I'm an MLE at Arize, because these sessions are also going to be available on demand. I'm here with Sid from Devron. Sid, can you give a brief intro?
Absolutely, yeah. So I'm currently working as a ML manager at Devron. I've been with Devron since the last 2 years, since the inception of the company. Figuring out how to get a good product market fit, what kind of product is going to work and solve the issues related to data privacy, federated learning, and data access. And so I joined as head of research, researching more into these technologies, writing proposals, writing patents, and kind of thinking about how to productize these things. And now I've moved to more of an engineering role where I manage like the engineering, because even when I was head of research, I was like doing more engineering work. So I moved like more into the engineering role. So yeah, now I manage more of the machine learning tasks related to, writing algorithms for enabling federated machine learning, including, privacy and encryption technologies. And yeah, so we are a relatively we have a pretty decent sized machine learning team. And, we also have a platform team, but, more of machine learning. And before Devron, I did the Insight AI fellowship, with Amber, actually.
I didn't start the webinar. Hold on. Okay.
Okay.
All right. So I found there has to be 2 clicks to start the webinar. Okay. So now that we've officially started the webinar, I'm just going to intro myself. Hi, everyone. My name is Amber. I'm a machine learning engineer at Arize. I'm here today with Sid from Devron. Sid, I know you gave an intro. Technology is hard. So would you mind re-giving your intro?
Absolutely, yeah. So I'm currently working as a machine learning machine learning manager at Devron. I joined Devron 2 years back, and almost like from the beginning, from the inception, with Karthik, who's currently CEO and founder. And we wanted to productize the idea of federated machine learning and technology for privacy preserving machine learning. And I joined as a head of research, so I looked into the various types of technologies, reading papers, understanding what kind of technology we can productize, and whether it is like marketable. So I tried various tools available in the market, and then we finally figured that we need to build this ground up. And that's when I got more into the engineering part, and now I'm like entirely in like machine learning engineering. So now we have a decent sized team. We have like 25 people. Like, we raised our Series A this January from Tiger Global. And, so we are like pretty much growing, and I see a lot more traction and, want for privacy and privacy preserving technology in 2022 as opposed to 2020. Like in 2020, whenever we went and talked our product, people would ask, hey, what is privacy preserving? Like, what is federated? I don't need it. And now like there is a lot more traction. Before Devron, I was at Insight, like under Amber. I did the Insight AI fellowship. It was like an amazing experience, really, like, learning about all the different ways, startups and industry is different from academia. And before that, I did my PhD at University of Iowa, focused a lot on computer vision and, building like predictive models for, computational physics applications. So.
Interesting, going from computational physics to federated learning. A lot of very interesting problems to solve in both. So for folks that don't understand or like haven't come across federated learning, like how would you explain it to them?
Absolutely. So federated learning is a technology where you want to do machine learning, but you don't really have access to the data, or that you want to keep the data private and not move the data at all. The first example where federated learning was implemented was by Google for the Google Gboard. So we all have various types of typing habits, and Google predicts what is the next word that you are going to type in the keyboard. But in order to train that, if they took all the messages and everything that you've ever typed, there would be a lot of private information that Google would be collecting and storing in their central servers. So instead of that, Google they trained model in the phones themselves, and then those trained models were all collected in a central server and aggregated using an algorithm called federated averaging. And and then they were able to train these algorithms and then deploy those algorithms back in the phones to make better predictions. So this way, there were millions of devices, and you're getting data from all these. You're not getting data, but you were getting models that were trained on data from millions of these devices, but you are not really collecting all the data. So we at Devron, we are productizing this technology more for enterprise solutions. So in enterprise, there are a lot of situations where there are companies that want access to the data, but due to some privacy regulations, or even some governance, or even when the data is in a different country, geographic locations, privacy laws, they cannot get access to the data. So what we do is that through our platform, they can run machine learning models, go through the entire data science workflow without ever having access to the data. So that's kind of like what federated learning is. The idea is that the data stays where it is, but the model still trains.
Okay, so then how it relates to like federated systems. I think that was like in the show Silicon Valley, like where essentially it's like a type of, it's distributed and it's not, it kind of spreads like some responsibility too, would you say?
Mm-hmm.
Okay.
The data owner, I would say. So we have, in federated learning systems, there are two types of, I would say, user persona. There is a data owner persona, so that the ones who own the data, and there is a data scientist persona who is performing the data science operations. For example, like Amber, if you have some data that I want to train some models on and I cannot see the data, I could write some algorithm. I can still build a model. I can still write the algorithm to train, expecting that it will train on the data. So I will send the model to you, and then it trains on your own infrastructure, close to the data, and the data doesn't leave, and then I just get the model back. So that's kind of the idea.
Okay. And do you think this would also, because you mentioned like enterprise teams, do you think this would also have a lot of applications in academia where people can't like share their data sets?
Absolutely, that's a very good point. Actually, my co-advisor from University of Iowa started, like, he got an NIH proposal where he wanted to train federated learning algorithm on MRI images, so MRI image data. So multiple universities like Harvard, I think Stanford, and like a couple, like 5 universities, they all, like University of Iowa, they all collaborated, and they wanted to build one model, or like not one model necessarily, but like a global model that would have trained on different types of images that comes from different hospitals in those universities. So if there are many situations where various universities or hospitals, they want to collaborate, so they can collaborate using this technology.
Okay, so essentially like one model to rule them all, like robust,
Yes.
like train to all the data. Okay, that definitely makes sense. And yeah, like we've been seeing a lot more too with like, data ethics and data governance. And so teams that, would you say like the federated learning, like it's within teams and within like it could be from like company to company as well, like maybe it's like, hey, Google, like I know you have like all this data, you're not going to publish it all, but like I have a system, and even like nonprofits and things that don't have access to this, so like it could be like both within companies and from company to company.
Absolutely, that's like so good. So in Devron, we have these different models one of them we call like inter-organization collaboration and intra-organization collaboration. So one example would be, so if there is a company, let's say JP Morgan, so they have different different types of branches within JP Morgan. For example, they have the credit card transaction system, they have the banking system, they have some kind of loan system, and but each of those organizations cannot really transfer the data between each other. So even within the same organization, if they want to create some kind of model that's trained on all this different data, then they would need to use federated machine learning. In the same way, if there is, for example, the example that you gave was very good, like Google has a lot of data, and if there are some companies, and even we see that with a lot of financial organizations, there are some financial organizations with a lot of data, but any new organizations that wants to start and, and build some kind of fraud detection system, they cannot, because they are essentially, they don't have any way of accessing the data. So in such situation, federal organization could let these new startups or new companies to get access to the data without, to let them train on the data without really giving access. I've actually been approached by some non-profit organizations where they want to like build these models for where there are various types of situation, like for example, police cases where you try to profile each person, and based on that you try to make some predictions, but all of those information is like PIIs that you don't want to share. So in such situations, you can apply federated learning on like devices.
Okay, yeah, and even getting into like the fairness and bias aspects, how do you see this potentially like mitigating, just like potentially like bias in these models?
Yeah, absolutely. So bias is, if you think about bias, what happens is that a lot of times when we train some models, it's just trained on a similar type of data set. So it becomes more biased to that specific type of data set. So if we are just training models within the US boundaries, within the US territories, then we will get a certain type of data, and that brings like an automatic bias in the model. So if we can give a more variety of data to the model, like the more data, like it's not just about more data necessarily, but it's really about the variety of the data, the new information that comes in from the data that comes in from a different geographic location. That really helps create the models less biased. And you can also use the current algorithms that are used to like reduce bias and increase fairness in the models for federated learning. And we haven't got there yet at Devron, but that's definitely some of like our big goal for us.
Okay, and one thing I was thinking about is being able to look at like reproducibility and like how exactly like that would work if people are using like on all these different data sets, because I saw that's like one part of like Devron's mission is like the reproducibility aspect. So how would you get that if because like one of the big things even in academia is we looked at this explicitly and like so anyone could get the same results?
Yeah, that's a good question actually. So if you want to do like reproducibility, you need some form of access to train the model on that specific data. So we actually talk about this idea of a data marketplace, where instead of if you want to give access to your data, so currently like if you want someone to run some models, some like let's say like a Kaggle model, like some competition on a data, you have to give your data entirely to that person. But in federated setting, you could have give access to multiple people to run their models on your data for reproducibility, essentially. I don't know if that answers your question.
Yeah. Yeah. I mean, there's no other way to do it besides, having like the ground truth essentially for that data source. So I was also just thinking like how this would potentially work with like an ML observability platform like Arize, because with Arize, you don't have access to the data, just like what's surrounding the model. So like you retrain your model, you have your inputs and outputs and features. But what potentially could be like interesting is like if you do trouble, because you have to troubleshoot these models in production somehow, right? I don't know if you've already like looked into like how you troubleshoot these in production, like if it's at like the model level. But it would be cool if you could figure out like if something's wrong, what data set it came from, and even alert those people, like, kind of as an incentive, like, oh yeah, you let us train on your data. We're tracking all this and like putting it out in the real world. We can see if like there's something wrong potentially. I don't know, like how have you thought about like how to monitor these in production?
Yeah, absolutely. That is actually a very good point, because in federated machine learning, let's say I have, like I'm a data scientist and I'm training a model, and my data, and I have 5 different data sources. So what could end up happening is that one of them could have data that is either, we call it a model poisoning attack, where they want to poison the global model, or it could be just that the data quality in one of those data sources is so low that it is actually degrading the model, during the training process. So in federated machine learning, it's actually very important for us to kind of track and monitor what kind of, how each of these models are being trained and how much value is being added, during the training process. So it's actually a very, very important for us for federated learning. We currently have in-house, like we have built some metrics tracking system to track if the training is going in the right direction, or there is some kind of poisoning attack. We have also thought about the machine learning technique, where if you have trained a model from a specific data source and you realize that data source was a bad actor or like had a bad quality data, then you could unlearn those specific,
Ah,
uh,
machine
and
unlearning. I
yeah,
don't think I've heard that before. I like that. That's a good like.
it's
I wish I could unlearn bad habits too. That'd be great.
absolutely. There are papers. The first time I saw the paper on machine learning, I was like, wow, that's interesting. But definitely very applicable for federated learning.
Yeah, because I mean, even people that are happy to like supply their data like for the training, it should be like mutually beneficial. Because when I first thought of like, oh, allowing people to use like your data to train, it's like what's in it for the people who are allowing it to train? Well, there could be additional like labeling, corrections, making sure, like you said, like there's no like poisoning in it. Do you use like a lot of embeddings then with these models to try to get like I guess like a kind of more of a high level overview?
Yeah, that's a very good point. So we actually do something very interesting. So if you think about the model themselves and during the whole process of the model building, if you ask any data scientist, what will it say? What is the most important process? It's data cleaning, feature engineering, really understanding what the data looks like, really get a feel for it. Unfortunately, in federated machine learning, the data scientist cannot do that. And so what we do is that we use a synthetic data generation technique to give the data scientists some synthetic data to work with, and then they get an understanding. And we also give them some statistics on what the data, real raw data looks like, and some understanding of that. And so that like helps them drive those decisions to kind of get, what kind of features are there, what kind of, essentially like embeddings and things like that.
Okay, because Arize is releasing some embeddings, like being able to track embedding drift, like in the platform. And I was trying to think of like different common use cases with it, because it's really around like the data being off or different, or like especially if you retrain on a slightly different data set, like being able to see those distinct kind of distributions. Technology is really cool, like a lot of
Yeah,
interesting stuff you can do with it.
The way I think about federated learning is that it is not much different from machine learning. It's just machine learning, everything. Like we still have to think about drift. We still have to think about all the different ways, like large scale training. We have to think about production training, everything just the same way, but it's just that you cannot see the data, and rest all the machine learning pipeline and system, everything like still applies. So
I'm just curious, like who are the folks that like most want like federated machine learning? Like what's that persona? Are they like all different too?
So when we started in 2020, we were targeting DoD, Department of Defense, we were targeting fintech organizations, and we were targeting healthcare. And with time, because of our founders' connections with DoD, we actually got a lot of DoD projects, and we still have them. There are various situations where different organizations in DoD, they want to collaborate. And but we had to give up healthcare in some ways, at least for the time being, to create more focus for the business. So we are actually focusing more on fintech right now. So we have seen that for, there are various types of fintech organizations and large enterprise organization who essentially either they own the data and they want someone else to get access to the data without really giving keeping the ownership of the data,
Right.
or they want access to some data, but they cannot because of some privacy and restrictions. So we have actually, most of our customers right now are in the fintech, commercial customers are in the fintech area, and we have government customers in the DoD.
Okay, interesting. Yeah, because like you would think it, at least from like my perspective, it's like, okay, folks that really want to train their models. So I remember how difficult, it can be like when you're learning how to train a model and like, all right, I guess I'm going to Kaggle. Like there's not a whole lot of options to get your hands on, data sets people haven't seen a lot of times before. So like especially if you're more like a citizen data scientist, even like wanting to be able to explore these data sets, find interesting things. And a lot of people would be willing to do it for free if a fintech company was like, yeah, we'll give you access and see what you can find. It'd be really cool just in terms of like a learning experience. Do you see that potentially being like even like a community around federated learning? Yeah.
That's like the final,
Yeah.
utopian goal of the system, that everyone has some form of access to the data. Everyone gets to keep their data private. None of your data leaves, all your private information is protected, but you still get the benefits of machine learning. That's like in some ways the final goal. Like when I was talking about the data marketplace idea, that's the idea, because there are a lot of people who would want to kind of sell, the data, but not really give ownership for running machine learning models, to get analytics. But there will be others who would want like a community to build models on the data, but they cannot share it. Like I can see this being massive, especially in healthcare, where healthcare organizations, they cannot, if you want to do some kind of data science on this healthcare data, you usually cannot because of PIIs.
Right. Yeah. And because that's interesting too, because like a lot of the healthcare, there's some companies that will take out sensitive groups or try to really monitor for proxies, but healthcare is one of the few that they need that PII to make, because certain groups are more susceptible to diseases and need certain doses and dosages for medication. So yeah, healthcare is very interesting and difficult use case, but I know you'll get there. But yeah, It's definitely
It's a difficult industry to crack, but we're definitely that's a target that we do have for sure. Yeah.
okay. And then like because it's data privacy, data governance, like what are steps people have to think about like in order to implement it? Like if you say like, if okay, like we agreed, like you really want federated machine learning, like this is kind of our step one or step two, for like how we make sure that it's your data secure.
Yeah, that's again a very, very good point. So when we federated machine learning is the step one, because you own your data and then someone runs data science, some kind of machine learning on the data. But again, there are people are coming up with the model inversion attacks, trying to, it's extremely difficult. Like they have to really, really work hard to kind of try to invert and do some kind of membership inference attacks. So for example, if I have trained my model on some data, where, Amber's data, for example, I could do a membership, theoretically, I could do a membership inference attack to see, oh, Amber was in this data set where I trained this model. So there are some kind of, ways in which we can still improve post-federated learning. So that's why there are other technologies like differential privacy that smooths the data set. So as the model is training, you kind of smooth, so no one data point really shows up in the model. That's kind of like a very like a simple way of saying it. And then there are other encryption technologies.
Yeah.
So encryption technologies, what they do is that through encryption, you have data models coming in from 5 different locations. You could do an secure aggregation so that you can only see the aggregated model, not the individual model coming from each data source. So there are so many different levels you can go to increase, like, privacy and of the data. So
Yeah. Well, that's super interesting, Sid. Like I remember when I think like you first started there and you're like, it's a lot of stuff, and it sounds like you spent like 2 years really like diving in deep here. And a question I always like to end with too is like, what is kind of like your favorite part of the day-to-day, and like what's also the most challenging? Like sometimes it's the same for people, and then sometimes they're like two completely different things. So like what do you enjoy the most like day to day, and then what tends to be the most challenging part?
yeah, my favorite part is that I love coding, and I love really delving into these problems, trying to solve. Sometimes there are some days where I will be reading papers, really understanding this new technology, and then trying to implement it. And there's a satisfaction that I get when I can actually deploy that product and someone is actually using it. That is, I think, the most satisfying part of my job. And then there are others that are more difficult, more challenging, is trying to manage time between meetings, and then I have to get back to coding, and I have to think so much about my schedule to bring in get some deep focus work. So that's challenging, I would say.
Yeah. It's kind of interesting too, because like since we were both from academia, like those 2 points you mentioned, like one was like the best part about academia, which was you pretty much had like a whole schedule to really dive in. And then like one of the worst parts of academia, which was like, this doesn't even get in the hands of people for maybe a decade, or it's like having like an instant time to value, and you can see how it's impacting folks. It is really, really cool in the industry. Well, thanks so much, Sid. I had so much fun catching up. Really cool stuff. And yeah, I'll definitely send over the write-up when it's done.
Thank you very much, Amber. It was wonderful. Yeah, thanks for having me.
Yeah, no problem. All right, have a great rest of your day. Bye.